Aquaculture in Norway, it's primarily salmon, and it's Norway's second largest export. My name is Sveinung Orem. I'm the research manager for the Aquaculture, Robotics and Automation Group at SINTEF Ocean here in Trondheim, Norway.
I'm Marios Xanthidis. I'm a research scientist in SINTEF Ocean. I specialize on real-time decision making, autonomous inspections, autonomous navigation underwater.
Norway has this unique geography where it has all of these fjords, so you have a lot of sheltered waters, which makes it ideal to do the sea-based aquaculture, which you don't find many other places in the world. So this is why 99.9% of all our production is sea-based. Aquaculture had its humble beginnings in the 70s and has since grown into a very, very large industry. There are about 1,000 locations along the coast of Norway where you have fish farming. Each location will have maybe between 4 and 16 cages or net pens, where each pen can have up to 200,000 fish at one time. So the scale is pretty huge, and I guess that's one of the challenges, is to see how the aquaculture industry can keep increasing while also maintaining the fish welfare and dealing with challenges such as mortality rates, sea lice.
There is an interest, and the industry is realizing that technology is really needed in order to target the current and the future challenges that the industry is facing. I'm Eleni Kelasiri. I'm a professor at NTNU, leading the field robotics lab here. We're working on how to develop resilient robotic systems that could be operating in very complex environments.
Technology in aquaculture, it ranges from production-related technologies, the infrastructure, the nets, the floaters, the mooring lines, these kind of more mechanical systems. Then you have, on top of this, more of the high-tech stuff that's been developing over the past maybe 5-10 years, gathering the data, visualizing it to the farmers and the operators. And then you have, of course, robots that are used primarily for inspection and cleaning.
Robotics the last decade has been one of the targets of the industry.
Academically speaking, it's a very, very difficult problem. Like underwater robotics, among most of my peers, is one of the most interesting and difficult domain to work on. I like motion planning, so practically how a robot can go from A to B while doing some specific tasks in between. Inspection could be one, cleaning could be another one.
Right now there are hundreds of robots, if not thousands of robots, operating in aquaculture in Norway. And I think that's also a unique thing with aquaculture, is you typically want 1, maybe 2 robots per pen. Say you have 8 per location, and you have 1,000 locations in Norway, so that's a lot of robots. So the scale is huge. You can't have 8,000 people controlling 8,000 robots. That's not economically or practically feasible. So the level of autonomy in all of these robots need to be increased.
They need to have systems that are autonomously able to navigate, observe, collect data, analyze, and give the status of their structures, of their biomass, and also of the environment. What we are doing is we're trying to develop methods to make these systems more autonomous and be less man-dependent.
SINTEF Ocean, as a research institute, we have 4 research licenses for farming fish. And we are operating these licenses in a collaboration with the SalMar. You have the fish farmers, and you have a huge service industry operating around the farmers, supplying everything from equipment to personnel to research.
Big part of my research is to be out and testing the system. The information you get when you are actually in the field, you cannot gain it from your office. That opens up and makes you to realize what is the scale of the challenges or the scale of the facilities.
More or less, the cages are moving further from the shore, so have more wild conditions in a sense. The cages are becoming larger, so of course it's more difficult to operate there.
We always like to demonstrate or test our systems in the most harsh scenarios, and if it works in such situations, then it would be more suitable to adapt it for other domains. So that's kind of the excitement brought the interest towards the aquaculture.
We like to involve students in most of our projects, I guess for two reasons. It's nice to get us extra hands on the problem and to keep up collaborations with universities, both here in Norway and abroad. So kind of to build the network and maintain the network. We work with you at MIT, and you have this excellent program where you kind of ask and find students, and we define the problems at our end.
Aquaculture is quite interdisciplinary in the sense that we need the students to have a background both from biology and technology. And this is what we're trying to integrate here. So we have students that are very good on computer vision. They can do analysis of the data we're collecting, or to do very detailed models of the structures of the vehicles, of the fish, and how they are changing their behavior. This is the beauty when you can combine the topics in order to understand the biology-technology interaction.
Fish welfare is kind of the main driver, I'd say, for all the companies that are operating. So the big question is, I guess, how can you kind of ensure that?
Everything is moving, fish is moving, and we need to interact with all these dynamically changing components when we are doing robotic solutions. So that kind of open up new directions. We cannot develop technologies that are applied for industries where we don't have biological components and then apply them somewhere where we have a live fish or other live organisms.
For me, aquaculture is exciting, again, as a roboticist, because it fundamentally challenges fundamental concepts and assumptions that most high-tech methods out there have in robotics.
When I was in SINTEF as a senior researcher, we had a really close collaboration, and we continue with MIT Sea Grant and with Professor Trondheim and Professor Sapsis, developing underwater vehicles dedicated to aquaculture. We worked closely on developing methods, controllers, models. I just want to mention the importance of collaboration between different institutes and different parts of the world.
You get more out of each project.
So if you are willing to learn and you have the passion and the motivation for that problem, then I think this builds in a great team. We need to try to target that problem and let's solve it together.